Hi everyone, a very good evening to all of you. Now we are going to study about the question number 26 that is related to the acceleration of system of blocks kept in contact. Last class we have seen the acceleration of system of blocks connected with string. Now we are going to see the acceleration of the blocks kept in contact. Now to understand these questions, the very first thing is only one thing we need to understand what is normal force and its direction especially. When there is a contact, like this is one body and one body placed above it. Or this is one body and one body kept in contact. Or this is one body and kept in contact another body. Now here perpendicular to surface there is a force. Here perpendicular to surfaces there is a force. Here, perpendicular to surfaces, there is a force, equal and opposite on each of the particle. But here, if you take the first case, lower particle will get the force downward, upper particle will get the force upward. Similarly, in second case, rightward particle will get, right side particle will get experience normal reaction rightward and left side particle will get experience force rightward. Same the way in case of inclined plane. So the upper block gets the force upward direction, lower wedge gets the force downward direction. But as it is inclined plane at some angle, let's take the angle of inclination theta. This is the first thing we need to understand. Then after that, what is non-inertial frame and its effect on acceleration of block attached to non-inertial frame? So non-inertial frame means a frame whose acceleration is not zero. That is called non-inertial frame. Now, when there is a non-inertial frame moving with some acceleration and a particle of mass m attached, then pseudo force. Pseudo force is an imaginary force, acts on the body, acts on the particle which is attached to non-inertial frame, and the magnitude of pseudo force is given by mass of the particle times acceleration of the frame. So sometimes they can ask the question based on this also. Now, what is the acceleration of a block kept on inclined plane at rest or in motion? Now, when you take inclined plane and a block of mass kept on it, then it is coming down. Then you have to draw the free body diagram like number of forces acting first. Then you will choose the direction of motion as x and perpendicular as y, and then you will go for the components along x and y. So that if this is theta, then this is theta. So the component perpendicular will become mg cos theta. Component along the incline will become mg sin theta. Now y direction, no motion. That means forces must balance each other. So n should be equal to mg cos theta. So the resultant force is along x-axis, that is mg sin theta. But resultant force means mass into acceleration. So that acceleration equal to g sin theta. Also here you take a note that when multiple blocks kept in contact and you are applying some force on a smooth surface, then acceleration is force by total mass. Like m1, m2, m3, m4, so on. Like this. Up to mn you consider. Now at any common surface, let's take here, normal reaction means total mass pushed at that point times acceleration. So the total mass pushed by that is m4 plus m5 plus so on up to mn times acceleration. So this is one of the important things. So based on which you can solve the question, simple questions based on the blocks kept in contact. Now let's see a few examples based on these things. So first thing is three blocks of masses m1, m2 and m3 are connected by massless string and placed on horizontal frictionless surface as shown in figure. A force F equal to 12 Newton is applied to mass m1 as shown. The contact force acting on mass m3. Now first thing is acceleration. Acceleration means, as I said, total force by total mass m1 plus m2 plus m3. That is, force is 12 and the total mass is 1 plus 2 plus 3. So 12 by 6 is 2 meter per second square. Now the normal reaction on M3 means here. So here normal reaction means that is total mass pushed by it, that is M3 times acceleration. So M3 is 3, 3 into 2, how much? 6 Newton. So this way you need to find the same thing. Now suppose two blocks are kept here. Now the acceleration of the system. Again, very simple thing. Acceleration equal to force by m1 plus m2. They have given m1 is 5 kg and m2 is 3 kg and the force applied is 4 Newton. Then they are just asking acceleration of 3 kg. But as they are kept in contact, they must move with common acceleration, and that common acceleration is force by mass m1 plus m2, 5 plus 3, that is 1 by 2 or 0.5 meter per second square. Now let's take one question based on the inclined surface. A block is kept on a frictionless inclined surface with angle of inclination alpha. The incline is given an acceleration a to keep the block stationary, then a is equal to. Here when inclined plane is there and block is kept on it, it will come down with an acceleration g sine theta. That is what we have seen. But here in this case, what they have done is they have given some acceleration a, so that apart from normal reaction and mg, there is also one more force, pseudo force, mass of the particle times acceleration of the frame will act, and such that they are telling it is in equilibrium. So that, see, this component is mg cos theta and this component is mg sin theta. That is what we have seen already. Now this is theta means angle of inclination. Now this is also theta. So this component will become MA cos theta and this component will become MA sin theta. Now along y direction, if you consider, the forces must balance. That means n value should be equal to mg cos theta plus MA sin theta. That is y direction. Now along x direction also forces must balance because we have given some additional acceleration to the wedge. Now it will become non-inertial frame such that the block remains at rest. That means the upward MA cos theta must be balanced by the downward mg sin theta along the inclined plane. So A get cancelled, implies A equal to g tan theta, or according to that alpha, g tan alpha. This is how you need to solve the question related to non-inertial frame. Sometimes based on that formula, direct question also they can ask. Now here they have not given any diagram, just they have given the question. You need to understand, and if needed, you need to draw the diagram also. Two blocks of masses 2 kg and 1 kg are in contact with each other on a frictionless table. When a horizontal force of 3 Newton is applied to the block of mass 2 kg, the value of the force of contact between the two blocks. See here, 2 kg and 1 kg are in contact with each other. So this is 2 kg and this is 1 kg. Now when a force of 3 Newton applied to the block of, now force is applied on 2 kg. That is also important. How much? 3 Newton. The value of force of contact between them. First, acceleration. Acceleration means force by mass, m1 plus m2. Now 3 by 2 plus 1, 3. So acceleration is 1 meter per second square. Now here, normal reaction means it is pushing 1 kg. So 1 into acceleration is 1. So 1 Newton. Because if you are applying force on 1 kg, then the normal reaction will become 2 into A. So the value changes. But acceleration remains same. That is the difference between on which block you are applying force. That also matters. That also decides normal reaction between the blocks. Now one last and final question. Consider the following statement about the blocks shown in the diagram that are being pushed by a constant force on a frictionless table. All blocks move with the same acceleration. The net force on each block is same. See, one thing is for sure that all will move with the same acceleration that we know already. A equal to F by m1 plus m2 plus m3. But the force between, normal reaction between 2 and 3 means that is pushing 2 and 1 both. So that means 2 plus 1 into acceleration. And the normal reaction between 2 and 1 means it is pushing only 1 kg. So 1 into A. That means the net force on each block is, normal reaction on each block is not same. But here the question is the net force on each block is the same. So net force means what? Resultant force. Resultant force means what? Mass into acceleration. So normal reaction is not same, and similar way resultant force on any particle is mass into acceleration. Acceleration same, but mass is different. Therefore, resultant force is also different. So first statement is correct, but second statement is not correct. Now similar questions also I have given as assignment. So please try to understand and just try to find on your own. So simple questions. So here I have given the combination of like inclined with vertical, and here I have given the question based on the inclined surface where the acceleration of inclined surface is g sin theta. And here the question is, see, the above question already we have done. In that, they are asking one more question. So please just try to solve it. So this is how we deal with the finding acceleration of the body is kept in contact. So we'll continue in the next session with another topic. Thank you all of you.